Okay, today we will discuss the same thing. In compute engine, we have created an instance. While creating instance, so we have created the instance group. We have created the instance template. In the real time, basically, as we discussed, first we need to decide the zone. Once we decide the zone, then we will create the our admin or architect will decide or create the images if possible. Okay, what is image? Yesterday we have seen creating the disk, creating instance template, creating the instance groups, right? Image is nothing but one particular operating system we can create an image. These are the list of images are available. Okay, instead of taking the different operating systems with the different versions, you can directly select the images also while creating the instance. Okay. Basically, we have seen the difference between app engine. No, sorry, we have seen the difference between IaaS infrastructure as a service, platform as a service, and software as a service, right? So we'll see the next app engine. Before app engine, I wanted to explain what is app engine, what is compute engine, what is container engine. Kubernetes is nothing but container engine. Okay. Yeah, if you want to host any website on normal premises, on premises, just we need to take the web application, right? Our application server, web server, application server. Then on top of the application server, basically we will deploy or host a website, right? Here instead of using on premises, we are going to use Google Cloud platform. Okay, so first we will use the Google Cloud storage. Okay, and then compute engine will execute the computing it, and the app engine will deploy the application on the container. Okay, here we have a Google container engine is there. On top of the container engine, the computing and the deployment will be happen. Okay, basically what we will do in app engine, what can we do in container engine and compute engine. Okay, so in compute engine, first I'll start with from here to here. In compute engine, you need to complete the complete control over your infrastructure. So I wanted to implement a one .NET application or Java application. I think all of you know what is web application, right? Any doubt on that web application? Yes, Sudhir. Yes, Rahman. What about you? Do you know web application? The application which runs on web. Yeah, okay, fine. So basically, we will build a Java classes, Java files, and we'll yeah, compile all the things and execute. After that, we can create a web file. Okay, so that web file will be hosted or deployed on some application server or web server, which can we call it as a container servers. These can be called as a containers. Okay. So here, when you use compute engine, only compute engine, you need to worry about infrastructure. You need to access everything in the everything should be done from your end only. Okay, you need to worry about the SSD software cycles and development toolkit. Everything you need to create in local. Okay, so if you use container engine, okay, already infrastructure will be taken care. Only the container engine will be useful if you want to increase the velocity, if you want to increase the operability dynamically, improve the performance, improve the resources, then you can go for the container engine. The app engine will be useful for so you will focus only writing the code. Okay, focus on writing the code. You need not worry about the what kind of operating system you are using, what is the Java version, and are we using Git or are we using Maven. All those things are not need not worry about it. Everything will be taken care about compute engine. After on top of that, container engine will be there. So when you use app engine internally, it will arrange all the things. Okay. So you need not worry about, you need not to touch the any server cluster or infrastructure. Everything will be available. App Engine will be useful for directly write the code and deploy the application on the server. Okay, here we are not calling it as a server. It's a serverless architecture. Without having any server, without creating or without restarting any server, directly you can deploy it. Okay, understood this point? Yeah, here, yeah, in App Engine, you need not worry about the which operating system you are running your code, whether it is Windows, Linux, or Ubuntu, doesn't matter. Okay, and here you don't have dependencies on the specific operating system. Here in container also, you need not worry about the operating system. Container will take care about it. Underlying container, it will take the operating system. So when you are in the container, so you will see only the space for deployment. That's it. Okay. In computing engine, you need to make operating system, which version, what is operating system you want to, what are the levels of usages you want, everything you need to take here. And you need to provide your own network and graphic drivers and all these things, and any performance related things, improvement related things, security related things, everything you need to take care about here. Okay. The compute engine. Compute engine will only compute the things, but here app engine will ready made for deploying the things. And one more slide for these things, so then you can easily understand the what exactly the difference between these three things. All these three comes under computing, right? App engine, container engine, and computing engine. You can see here, all these are compute comes under compute category. App, compute, and Kubernetes. In app engine, basically we will deploy the websites or mobile apps or gaming, whatever it may be, whatever the applications which will be used by end user. Once you deploy or no, push or publish an application, any app, that is nothing but after that the end user can easily use it, right? So the after a web application, end user can access the application. But container engine is different. It is a centralized workloads. It will be useful for all the applications. It is not for only one application. Container engine will be useful for all the application across the industry, across the, I can say across the company. Okay. Here, any workload required specific to the one operating system, specific to one configuration. In the next slide, you can get more clarity how exactly the container engine will work, how exactly compute engine will work. Okay. Here in App Engine, we can use the RESTful APIs. Okay. Application API, application programming interfaces. API is nothing but application programming interface. So RESTful APIs, web services, RESTful, stateful, stateless, right? Those kind of request, if you want to send directly, you can send to App Engine, you can get the response. Okay, but nowadays on top of this, advanced one is the microservices. Microservices is more advanced than RESTful APIs. RESTful APIs is again will take little more time, but microservices are very good in the performance level. We will discuss maybe after 1 week. Okay, and now we can deploy all kind of Internet of Things applications also in App Engine. Yeah, directly. Okay, so when this is the completely middleware. Container engine will be like a DevOps related thing. Here we can use the Jenkins, and here we can use the Docker related things also. We can use internally. The GCP will use some DevOps related things. Okay. So here compute engine is completely depending upon the operating system and the VMware, VMs images. and here it mix and match. Okay, so here we can use two three things at a same time also. Okay, we can use the app engine for front end services purpose, front end application, while running the any database in the back end as a compute engine. So in the same application, same project, we can use all the things also at a time. Okay, Redis is nothing but it's a one of the NoSQL database. Okay, which will be very faster one, key value based database name is. So maybe we can run the this NoSQL database in the compute engine, and we can run the application as a web application as a web engine, app engine. Okay, and here you can see the container engine can be used for rendering the microservices that uses in compute engine. A computing engine will compute the data, right? Computing in VMware is running Windows. Okay, actually frame and render. So based on the situation, we can use here. We can all use container engine as well as compute engine. See again, yeah, app engine can be used front end application as a web application. Cloud SQL as your database. You can use that in the container engine. Okay. So like that, based on the situation, we can select the which compute area you want to use. Where can we use it? Okay. Here you can see the main differences between containers and VMs. As of now, we discussed, right? VMs is a virtual machine which will provide you environment, or you can say platform to execute our applications after infrastructure. Okay, so here you can see the main difference. The containers will be like, suppose you have a one application A is there, application B, application C, three different applications are there. Okay, so I have completed the application development. I wanted to deploy it here and here also. So it's a binary files and libraries and other required things are need to add, right? We need to add all these bins and libraries. What is bin and library? You can see I'll show you how will be the web application, web folder structure. See here, this is the web application folder structure. This is fixed one. So this is my application name, my web app name. Suppose if my application is insurance company, insurance app. In that app, you can see web and hyphen inf is the folder is mandatory. Name itself web enough. In that web enough, you can see libraries, right? This is called showing libs, and the binary files will be which is executing like a, where is this, yeah, it's like executing like a, here all directories are within the directories. We have a different kinds of libraries available, and other files are available, supporting files, and these classes are available. Okay, so all these things will be included within the app, then only it will be treated as a web application. If there is no web enough folder is not there, then it will not treat. All classes are having the Java class files, all supporting library files. This is the configuration file, how my web application will be deployed and executed. Okay, like this. So binary files and libraries are there. After that, in virtual box, virtual machines, VM machines, if I am running my web application in on premises or in cloud direct VMs, so I need to select the operating system. Okay, so I need to select the, again for A also I need to select operating system. Here also I need to select individually. I need to choose for operating system. On top of that, it will be executing on the infrastructure. But when you use for container, you need not worry about the operating system. The all the application A, B, C all will be pointing to the container. Container is nothing but it can be a Docker, it can be a some other any DevOps container. Okay, so here it is executing on the container. Okay, so simply you can deploy on the container. Here also you can deploy, but within the Docker internally it will choose the which operating system we need to use. Okay, it will be like a proxy in between operating system and application, right? It's like a proxy. Here there is no proxy direct. So this is called container. The container we can easily deploy it, we can easily upgrade it, modify it other than operating system directly. Okay, when use container, the performance also will be good, and the scaling up, scale down also very good. Okay, here you can see the container engine basically it will be working as a master slave architecture. The container will be treated as a master. So the container engine can be called as a Kubernetes engine. Kubernetes is a different name which we can use it in different engines. The same kind of engine is available in other platforms also, in AWS and Azure also. So here these are the these are the pods are our applications. Okay, our things. So here it will be connected from here to here. So like a node instance 1, node instance 2, like this. Okay, so the performance will be very good, and whenever you want to redeploy, whenever you want to modify it, easily you can do it. You can make it automated. Do you see nowadays most of the applications are automating, right? With the help of DevOps. So once you developer is completed a development task, automatically the testing will be happen. Once the testing is completed, it will move to like this actually. First requirements gathering, right? So after that technical design document. Technical design document will be these two are the common things, and next plan. So previously, after planning, we are using development, then testing, then deploy or production. If anything happened in the deployment, then again it is coming to planning, which we can call it as a waterfall model, right? In few years back, the software development was using a waterfall model, but in the last 5 years most of the companies are not using waterfall model because of anything happened, any problem or any deviation happen, again we need to do the entire cycle, which is taking a lot of time as well as a lot of resources, right? And the budget also getting very high budget. So nowadays everybody using iterative based. Iterative based in the sense sprint based. Do you guys heard about sprint based? Any idea? Sprint based. Every time, yes, yeah. Sudhir, I think Sudhir knows. Yeah. And Rahman, Rajesh, do you heard about these things? Yeah, Scrum meeting. Yeah, small quantities like right. Yeah, it can be a Scrum. Oh, you heard about Scrum, right? Yeah, Scrum is nothing but is all are comes under the same area. Yeah, sprint is it's like a 2 to 4 weeks. Mostly will take 2 weeks. Every 2 weeks we need to complete end to end. Take the small requirement, may not, it not but complete thing, and complete that development testing and try to deploy it. Entire thing we need to do. Scrum is a discussion. Scrum meeting is a discussion every day in development area. We'll discuss, maybe it should not be more than 20 minutes basically. Scrum meeting. So in this discussion, entire team will be involved and they will discuss what we have done in yesterday, what are the bottlenecks, what we are doing to do today, and what is the next task. So simply cripsy and a simple small discussion. Okay, it's sprint based one. So here when you are when we are completing the development, the testing should be happen. Okay, in this testing, it is nowadays everybody using automation testing, right? So manual test is not required. When developer is completed, developer will move data to the repository called Git server or something, right? Right? Nowadays, most of the companies are using Git. I think you heard about Git, right? It's a repository. Maybe Rajesh, you may use CSV or CVS, some other repositories, but most of the people are using Git server. So there, did you heard about it? Git check-in, check-out, code check-in. Yes, yeah. Yeah, Git in Jenkins, right? Exactly. Git is separate, but Jenkins is integrated with this one. Okay, but once developer has completed this one, automatically Jenkins will take the code and will do the automation testing. If the testing is successfully completed, it will move to the next level, uh, next deployment. If testing is failed, again it will move to the development. Again, developer will take this one, and this completely automation, right, nowadays. So how deployment will happen? Because of the container engine. The container engine will be integrating with these things after development. Development cannot be automated. Development can be done by developers only, right? So then this one, after that, Git come from Git to testing, testing to deployment. If any things are there in between, these things also automated before deployment. Okay. So here the Docker container or whatever the container will be here, it will be taking care about the all the instances as a master slave architecture manner. Okay, got it. Today we are discussing more about into the theory part regarding the container engine, web engine, app engine. Okay, the container engine and these things, right? The main important things are the advantages of these things and disadvantages of virtual machines. You can see. Okay, container engines will virtualize the operating system. Okay, actually one operating system is there, virtual machine is there. It will use one virtual machine and virtualize with the different applications. Here directly it will take the hardware, virtualize hardware. Okay, here it will be more portability. Okay, portability is more. So based on the situation, based on the application, it can accommodate the operating system. Here it is a less portability. Okay, rebooting is very easy. We can reboot the container within the fraction of within the few seconds. You can easily reboot it. You need to worry about, but rebooting entire operating system will take little more time, right? But rebooting containers and application server is very easy. Sometimes we need to reboot because of the things when you deploy. Sometimes it may not be reflected on top of the new deployment. So sometimes we need to reboot. So when you use complete virtual machines, we need to reboot the complete machine. At this point of time, there may be other applications or other processes are maybe running in the same virtual machine, which will affect, right? But when you reboot the only container, no issue. We are not touching any operating system. We are touching only container. Operating system still running. Only container will be rebooting. Okay. Just the container will be the space is just in MBs only. Maybe 50 MB, 100 MB, 200 MB. That's it. But the virtual machines will be maintained. It requires GBs of space size will be maintaining. Okay, got it. Yeah, hi Ramkoti. I think you joined a little late, right? Yeah, Ramkoti, just we are discussing the all the engines regarding all three different engines: app engine, computing engine, and the container engine. Okay, you can get the recorded session. Okay, so basically, the instead of using virtual machine, you better to using container engine. That means we should not use direct virtual machine for web application deployment. That is the first point, right? So if you use web engine directly, it will be easy to hosting the web application. Okay, the main advantage, sir. So here, as you told you, right? As I told you, microservices are the next revolution in the services area. After that, web services, RESTful, RESTless web services. We have a microservices is a new thing. It's an architecture. When you use microservices in the cloud area, it will be a very easy, and it will give more performance. The container engines are the portability, completely portable, and it will allow the rapid deployment. How many times you want to deploy it, no matters. Even you can change a simple thing and you can redeploy. So it will not take much memory. It will not take much time. Immediately it will redeploy the things. Okay. And here it's an orchestration. Orchestration is nothing but it will use the internally Kubernetes cluster. Kubernetes cluster will take everything as a pieces, small pieces, as a master slave architecture internally within the container engine. So it will be completely working distributed manner. And again, here you can see image registration. Once you complete one particular container engine, if you complete one particular setup, then you can create one image on top of that. You can create an image on top of the particular container. So in future, if you want to use in for any web application, you need not worry about again all these things. You can directly pull the image from the container registry. Okay, once you create a first time base, right? So what type of container you want, what type of things you want, everything you can create. You can test one application. If that application is working properly, then we can create one image registration. Then it will be one image will be created on top of the container engine. Next time onwards, simply you can pull that container engine. That's it. Okay. And the container engine can be working with, it's completely flexible. You can work with other cloud providers also. No need to come work with only this one. If you create one container engine based application, the same web application can be worked with some other cloud providers also. Yeah, or else in on premises also it will work. Okay. This is not a rigid one. This is a flexible one, completely flexible. So, any more doubts as of now? Okay. So, yesterday we have created you can create in VMware anywhere directly. You can go and create, but App Engine we did not create any VMware, right? As we discussed. So that's the reason I have given clearly. In App Engine, we are not dealing with any virtual machine directly. See here, when I click on App Engine, you could not see any virtual machine, right? Here in the Kubernetes engine also, you can see directly a cluster only we are able to see, not able to see any VMs. So only the compute engine will dealing with the infrastructure. That is the reason you can create compute engine. If you click on compute engine, you can see already one uh, VM instance is running, right? Okay, so the zone is this. This is a zone, and these are the IP address and the SSH. SSH we have gone through this one, right? So you can click on this one. So yeah, we'll do some programming related things here. Okay, so I'll show you one Java application tomorrow. So you need not write any code, but just you need to ready with your that thing just so that we are going to use Java application. Okay, so here I think all of you are good at Linux Unix commands, right? If anybody still not at, please let me know. I will provide you some of the documents on yeah, okay. So there's documents on Linux Unix commands, base commands. So you can practice here. Just to simply create one VM instance and practice here. Okay. So first you can see the what are the zones are available here, and here you can see the health checkup and different things. So images. So you can create one image. That image can be directly, you can take one image. That image can be used anywhere. Okay. So you can select this one. You can save this as a image. Here you can see label. You can give some label here. Okay. And the disk is nothing but what kind of disk you want to use. So these disks can be used in the while creating the VM instances. Okay, just I'm coming back. So app computing engine is completely based on the uh, creating or preparing hardware and the operating system related things. Okay, next is the app engine. App engine will be useful for deploying or publishing the any web application or mobile application, right, or any other applications which can be reached to the end user. Okay, suppose if I enter some website name ebay.com. So what happened, this is like a web application only. When I enter this one, it will reach some container. Maybe eBay may be using on premises or cloud. It doesn't matter for end user, but that is nothing but when you enter some web URL, HTTP URL or HTTPS or URL, 100% it is going to reach one container or web application. So that means 100% millions of applications are running on containers, right? Web containers as an application. That is the reason the Google Cloud is focusing more on web computing. Okay, that means app engine, application engine. In application engine, first you need to go for the dashboard here. Okay, here we need to, the first step is we need to select the what is the programming language you are using for creating the application. Okay, already you can see the app engine will giving a sample that hello world is a sample application. It is providing by default. Okay, so we can use that one for testing purpose, or else we can create our own application. Okay, so here you can select the language. So these are different languages are available. You can select any one of the language. So mostly we are using Java or Python. Okay, Node.js. How many of you are not aware about these things? Ruby or Go? Do you know what is Go language? Go language, it's not really new, but it's new to the industry. Nowadays, many people are using in the big data area and artificial intelligence area. Go language is from Google language. That's it. Go is from Google. That's the reason is focusing. We are using Google Cloud Platform, right? So they're providing Go language also. So here we need to select the language. So this one, Scala is not updated. If so, Java is there. If you want to add any new language, also you can add it. Once you start here, you can see on the right side, it is providing build and run your Hello World app. Okay, so then you can click on continue. So already I have created a Satish branch. When I'm creating my Google Cloud Platform itself, I need to provide this one. Yes, Ramkoti. Yeah, Go language is a new language, right? So we are not using. So if you want to use, yeah, you can get it from Google. I'll provide you the Unix material, Unix commands, basic Unix commands, which can be used with a normal Unix as well as in the big data area also. Okay, this is the project. If you create any different project, you can select a different project. As of now, just you can create. I'm showing just overview. Tomorrow we'll discuss very clearly the how to work with App Engine. Okay, so here it is telling clearly, once already Java application is available, they have created a Java program with hello world.java, which will display the hello world. Okay, so they're telling open the Google Cloud Shell. See here, you did not write any code, or even you did not worry about anything. Everything is given. Open Cloud Shell by clicking this button. Where is this button is available? Here, right? From the navigation bar at the top. Show me how if you want to get it. So just you can click on the active Google Cloud Shell. Then shell will be open in the bottom itself. Okay. Once we are open, it is connecting. It will come to the command prompt here. Once it is coming to command prompt here, just I have taken all the uh, commands here. Just a moment. Okay, these are the commands which we can take directly. Okay, cd tutor, just we are creating a directory, and using this directory we are show, you can see the Java program, you can see the pom.xml. Okay, you can use the maven app engine.run. We are just running the maven. I'll show you that everything will be provided here. Okay, first you are taking this tutorial dir is equal to, we are taking this one as the command. Here you can see src directory is there. Already it is created in the Satish project. I have created, it is created with one directory with my project and project ID. After that, it is providing Java quick start with, along with the date and time. Okay, some date 15th I have created it. So let's forget about this one. Everything will be provided here itself. Just you can copy here, and you can run on Control V. Okay, see now it is created with today's date 19. Just enter. Okay, after that, one more thing, git clone. Then what will happen when you run this git clone? Git clone https, it is, see, you need not worry about the git is available or not. It are in real requirement, you need to know where exactly git is available, what is the git server. I need to install and download and install git client in my machine. I should know how to check in, check out all these things, but here I needn't worry about it. Already git is available. You can copy this one, you can put it in sorry, git. I'm taking only clone is nothing but I am getting the complete git Java code from git to local. Okay, see here. This is the app engine try Java. Already Google is created and checked in the git server. That is we are using. This is the source. See Java web app. See, do you remember I told you web and hyphen enough is mandatory for the web application. So already this is created. So you need not worry about all these things. Directly can deploy. But yeah, you should know what should be the internal things, how it is running, right? So that's what I am showing. If you click this one, you can see web.xml is there. Okay, and some other XMLs are there, right? And I'm coming back. Here you can see this is the Java class demo servlet.java is there. This is the Java file. Okay, so this is the Java code which is already created. So in real time, as a developer, you will create this Java program. Even entire template will be available. Only thing you need to worry about writing this code within the function. That's it. Everything will be created. As a developer, directly you can focus on this. So for this, you need not be a perfect Java programmer. If you know core Java, basic things is more than enough. Okay. As a cloud engineer, a cloud developer, so you need not worry about writing complete Java code and until unless your application is completely based out of Java, or else if based out of other things. So you can involve into the mainly cloud related things, how to deploy, how to do the things with the help of these commands. Maybe first 2 to 3 times it will be difficult. After that it will be very easy. Okay. Now just I'm entering here, you can see now it's cloning in the sense the entire Java code is downloading from GitHub server to my local machine, this one. Okay, next is the CD tutorial directory. Okay, tutorial directory is nothing but this is my tutorial directory. Okay, ls I can use ls. You can see here previously there was no data here. Now it is created all the things, pom.xml, readme. Okay, setup, got it. These are the things, what are the required things are here. All those things are the pom.xml. All these are the stuff, web applications of which is available in GitHub server, that is copied here, that is copied here, right? Src source is there, you can go and see cd src ll or ls main cd main ls. You can see Java web app, right? cd Java my app ls. You can see demo servlet dot java cat demo servlet Java. You can see here this is the Java program, right? So if you want to see what is exactly the Java program and other things, you can see here. CD, I'm coming back again. Control L will clear the complete this one. If you are not good at here, you can open separate window also. Okay. So now just copy this one. Okay, again I came to my folder, today's folder date. Okay, then completed, right? Next, continue. Next you can see cat demo servlet Java, already we have seen, right? In the src main Java, you need not worry about the path also, it is providing complete path also. Okay, to explore the application, to see what exactly the data is there, what you want to change. If you want to change anything, you can change it. Okay, so developing here is very difficult, right? Changing the code also. For that, we have one more option. I will tell you. You can create a one local environment and you can integrate with local to cloud also. Okay. Next, cat pom.xml. So it will show you what is XML file. Okay. So I think Java application, who has developed Java application, they can easily understand this one. So what exactly will be available here? If you want, I can explain in the next session. Okay, next, continue. Cat pom.xml, this is also fine. Continue. Now we need to execute the app engine run. When you execute this command, it will start executing the all the things. Sorry, just a copy. Now it will start deploying the things as per the Maven. Maven is a it's in Java without getting any jar files. Automatically, it will pull the all the jar files. See, now it is doing all the things. As a cloud engineer, you need to just take the code from Git server and you can simply deploy it. That's it. See, dev app server is running. Here you can see, you can directly take this one. See here, web preview. You can preview port 8080. Mostly the web containers will take 8080. When you click on this one, you can see it is pointing to Google Cloud and it is running web application. See, hello world is a only this is the message we have in Java program. We'll change it tomorrow and we can execute. Now it is running. Anybody can run from anyone. Okay, just for testing, can you guys please try? I'm not sure here. Just I'm putting in chat window this one. Just to try to execute in your browser whether it is pointing to my cloud platform or not without having any permissions because of we are using HTTPS, right? Can you click on that link? Are you able to get hello world or not? Rajesh Rahman, can you try? Oh, yeah, what is the error, Rajesh? Okay, yeah, another error, exactly. Because of you're using HTTPS protocol, right? So yeah, fine, got it. So very simple. So just it is completed. Next, continue. You can see the preview. If you want to change anything, you can change it. You can now now it is running in our cloud, but we did not deploy still now. If you want to deploy, okay, you need to create one app and then you can do it. It is running now. Just control C. I'm terminating it now. Once I terminate it, just I can copy this one. Gcloud app create. Now it is creating an app. And next, you can deploy the application using the Gcloud app deploy. Okay. See, Gcloud config is setup is we are creating the setup, and we are again deploying with using Maven. Now it is again building and deploying. Not yet completed. It is still running. Uploading 10 files to Google Cloud Storage. Now it is really uploading to the Google Cloud Storage and updating the files. Okay, now it is completely deployed, really deployed in the previously it was just deployed in the container, not in the Google Cloud. Now in the Google Cloud App Engine it is deployed. Okay, got it. Can you click on this one now? Can you click on this one? Just have give now HTTP protocol. We'll see it is coming. HTTP protocol now it's completely deployed. Yes, exactly, right. See the difference. Previously, I have executed only in my container. It was not deployed. So it was for pointing to HTTPS within my cloud I am using. But now I have really deployed this application which can be used by anyone in the world. Just if I give that particular URL, simple, anyone, Satish Bras hyphen some number appspot.com. That's it, right? Very easily. So I can create one web application, my own, by using HTML or Java or PHP. Simply I can deploy it with free of cost also for some few days, at a few months at least. Got it? Is it working for others? Rahman, Ramkoti, Sudhir? Yes, yeah, fine. So this is yeah, just I have given the complete end-to-end web engine. Tomorrow we'll do very step by step, and after tomorrow session you have to do it 100%, one practice.